In this next unit, we're going to be talking a lot more about statistics. Today, we're going to talk about frequency distributions, and we're going to talk about measures of central tendency. So let's start with frequency distributions. So a frequency distribution is simply an overview of all the values that a variable takes on and how many times they occur. And we can use a table or we can use a histogram to represent a frequency distribution. So let's say we have a lot of data and we're trying to represent that data. Instead of representing every single data point, we want to somehow group these data points together so that we have a better overview of what exactly it is that we actually have. So take a look at example 1. A survey asked a random sample of 30 business executives for their recommendations as to the number of college credits in management that a business major should have. The results are shown below. Group the data into intervals, starting with 0 to 4, up through 30 to 34, and find the frequency of each interval. Okay, so this is all the data that was taken after asking this information from a survey. We have 30 pieces of data. Now we want to actually understand this data better, and so what this frequency distribution is going to do, it's going to organize our information, and it's also going to group things together so that we actually have a better understanding of where most of the recommendations are. So take all that data, and it said to group the data into intervals starting from 0 to 4. So I'm going to start off with that 0 to 4 college credits, and then I'm going to go up, so 5 to 9 for the next grouping. Now you want to keep your groupings to be the same length. So going from 0 to 4 to 5 to 9, that's the same length. What's going to happen is we are going to end up counting up how many of our data points fall under these. So we want to make sure, in order to more accurately portray the data, we want to have these intervals to be the same. So the next would be from 10 to 14, then 15 to 19, then 20 to 24, 25 to 29, up to 30 to 34. Okay, so now we are going to go ahead and look at what we have and see and count up how many are within each interval. So start with 0 to 4. And let's just go through our data. We see a 3, we see a 0, we see a 3 there. So there are 3 data points that fall into this interval from 0 to 4. We'll go to the next one, 5 to 9. We see a 9 there. We see 8. We see a 9, an 8. That looks like that's it. So we have 4. Next, from 10 to 14, we have a 14 there. We have a 12. We have a 12. And then we have another 12, a 14, and a 13. Okay, so altogether that's 6 data points. Next, from 15 to 19, we have the 16, 19, 17, 16, 19, and 18. So that looks like that is 8 data points. Next, from 20 to 24, we have the 22, 21, we have 20, 23, and 24. So there are 5 data points there. 25 to 29, so we have the 25 here. We have the 28, we have the 29, so that's 3. And then 30 to 34, looks like we just have that 34 there, so just 1. Now, if you were to take the number of frequencies that you've written here, this should add up to 30 because there were 30 data points. So if we've correctly counted up the frequencies, this should add up to the number of data points that you have. Now let's show how we can come up with a histogram with this. So along the bottom here, I've written the intervals, so 0 to 4, 5 to 9, all the way up to 30 to 34. And then along the y-axis, I'm writing the frequencies. Now I know this frequency only goes as high as 8, so I'm going to go ahead and make sure that we can see 8, and then we can just draw our bar graph here. So from 0 to 4, that's 3. 5 to 9 is 4. 10 to 14 is 6. 15 to 19 is 8. 20 to 24 is 5. 25 to 29 is 3. And 30 to 34 is 1. So you can see how there is kind of a consensus or a central tendency that these data points go towards, which is in that 15 to 19 interval. So both of these are frequency distributions, both in chart form and as a histogram. You might be able to see that the histogram might actually be more useful in terms of visualizing the data. Okay, let's move on to measures of central tendency. So the first measure of central tendency is the mean. It's also known as the arithmetic mean, and that's simply the sum of the numbers, so the sum of the data points, divided by the total number of numbers. So here's how we would express it. So the mean is equal to the sum of all the x's, so x would be any data point, so the sum of all the data points divided by n being the number of data points that you're working with. All right, take a look at example 2. The table below lists the number of bankruptcy petitions in thousands filed in the United States in the years 2004 to 2009. Find the mean number of bankruptcy petitions filed annually during this period. All right, so our data that we're working with is the number of petitions that were filed for each year. Now, how many data points do we have? It looks like we have 6. So we can go ahead and add all of those data points up and divide by 6. All right, this comes out to be 7736 divided by 6, which is about 1,289. Now, just because it's 1,289, we want to make sure that we are taking into account what the units are. And it says that the table is listing the number of bankruptcy petitions in thousands. So this is 1,289,000. So in other words, that's 1,289,000 is the mean number of bankruptcy petitions that were filed annually during the years 2004 to 2009. Okay, next we have what we call the mean of a grouped distribution. So this takes into account, well, sometimes you have so much information that you don't want to have to sum up every single data point. So what do? Well, this is where it relates back to frequency distributions. So frequency distributions tell you there are a certain number of data points within an interval. Once you have it grouped, then you can actually use that to make it a little easier for yourself. So the mean of a group distribution is the sum of the products of the frequencies and the midpoints of the intervals divided by the number of numbers, or the number of data points. All right, so in terms of writing this out, the mean of a grouped distribution is equal to the sum of x times f. So x is the midpoint of each of the intervals, and then f is going to be the frequency. How many times is there a data point within that interval? Once you multiply them all up, then you can sum them, and then you can divide by the number of data points that you have all together. So not just the number of numbers that were summed up on top, but it's the number of total data points that you have. All right, so listed below is the grouped frequency distribution for the 30 business executives described in example 1. Find the mean from the grouped frequency distribution. Okay, so this is what we had earlier in example 1. So rather than taking the 30 different data points and having to find the average, having to find the mean by summing them all up. Now 30 is actually not that bad, but if you had a lot of data and you wanted to make the process simpler and you had a frequency distribution, this is how you would do it. So first, we're going to find the midpoint of each interval. Now from 0 to 4, the midpoint is 2. 5 to 9, that's 7. Now if you're not sure how to find the midpoint, the easiest thing to do is to simply add 0 plus 4, and then divided by 2. 5 plus 9 divided by 2, and so on. You'll notice that it simply goes up by 5. So next is 12, then 17, then 22, 27, and 32. Now we need to find the product of the frequency times the midpoint. So the frequency times the midpoint, that's what I have here. M is the same as X, but for the purposes of what we have here, I wrote midpoint, so just so it's easier for you to see what it is we're working with. All right, so 3 times 2, that's 6, 4 times 7, 28, 6 times 12, 72, and you just do that for all of them. Now that you have each of those products, now you can add those products together, divided by 30. So you have 465 divided by 30, which comes out to be 15.5. Again, with 30, it's actually not that bad to simply sum up the 30 data points, but say you're working with hundreds of data points, if you're able to at least put them into a frequency distribution, it would actually be a lot faster than having to say you had 500 data points. If you had to sum up all those 500 data points and divide by 500, that's going to be a lot more work than if you were able to write it down into a frequency distribution. Say you were able to get it down to a frequency distribution such as this one, then you would only have to work with 7 values, and then that would make it a much simpler process. All right, the next measure of central tendency is the median. The median is the middle entry in a set of data arranged in either increasing or decreasing order. So typically we've always done putting data points in increasing order and then finding the middle entry. You could put it in decreasing order and then find the middle entry. It's still the middle entry. Now, if there's an even number of entries, the median is defined to be the mean of the 2 center entries. All right, look at example 4. Find the median for each list of numbers. All right, I'm going to go ahead and put it in increasing order. So we'll start with 5, then 7, 10, 11, 13, 15, 19, 30, 39. You can double check and make sure that we've accounted for all of them. If you want to cross them off as you go, that's fine. If you want to just count them up and make sure you didn't lose one. So it looks like in the original list, it looks like there were 9. And then in our list, it looks like we also have 9. So we're all set there. Now the middle entry, if you're crossing off numbers back and forth, that's fine. Just make sure you're crossing off the same number on both sides. So don't just continue crossing until there's one number left. You want to keep crossing until there's either 1 or 2 numbers left, making sure that there are the same number of numbers crossed out on the left and the right. All right, so the middle number here is 13, so the median is 13. All right, let's look at the second one. We have, looks like 6 numbers. We'll put them in order, so 32, 47, 59, 74, 81, and 153. Here we have 2 middle numbers, right? So you want to make sure as you're crossing off, you're not crossing off until you're left with just 74. That's not the middle number. You want to keep crossing off until you have either 1 or 2 numbers remaining, as long as you have the same number of numbers crossed out on the left and the right. All right, so 59 and 74. Since we have an even number of numbers, we're going to have to find the mean of the 2 middle numbers. So that would be 59 plus 74 divided by 2. And that's equal to 66.5. Right, the last measure of central tendency is the mode. This is the most frequent entry. It is the data point that shows up the most. Take a look at example 5. Find the mode for each list of numbers. So we're looking for any repeated numbers here. So it looks like the 55 shows up 3 times. So in this case, the mode is 55. Nothing else shows up as many times. If you look at the next one, we have 185 and 185, but we also have 187 and 187. So in this case, there are 2 modes, 185 and 187. In the last one, it looks like we don't have any numbers that repeat. So in this case, we would say there is no mode. Now note the difference between B and C. In B, we want to say both 185 and 187 are the mode because they both appear more often than the rest of the data points. In the last one, we want to say there's no mode because there are no data points that appear more frequently than any other data point.